Hello, I'm Amitesh Singh from Team Dimes, and today is day two of reverse engineering category. Uh, Today I will be discussing a challenge. Since you guys already had an introduction yesterday, I'll be explaining how to apply all those techniques and all that concept, all those concepts in how to solve a challenge. So that is today's agenda. We'll start now only. So wait. So this is the this is the source code of the challenge that I have come up with. It's a pretty simple challenge, and I'll be going on how to solve this challenge today. Uh, so since most of the reversing challenges are compiled, you'll get the binary of the challenge, not the source code. I'll be compiling it and showing you how it looks in Ada. Uh, that's the compiled. Uh, Before usually starting a reversing challenge, you triage to the challenge as well, like you see what the behavior of the challenge is. Uh, You might know the strings command in Linux, which gives all the strings that is there in the file and displays it to you. So that's what we usually start with. Uh, so I do strings and not compiled binary. You can see it's a lot of things are usually are like things gibberish. Like they do make sense. This is all the knowledge, linkage files, all the instance library functions, stuff like that. The part we are English, like this part sometimes is like what kind of a like what the source code was written in. Like sometimes it might be missed or go. This is written in C. So you can see in this C, in the C.so.6. So it tells you that it's written in C. The part we are interested in is this. Enter password. Here you got password. Uh, for this entire part. This chances now like and also do file on the challenge. Like this tells you like what kind of file is this. It's dynamically like the this means that the language functions they will be linked dynamically like during runtime. So not stored from before. So this like reduces the storage but like reduces the speed. So that is that not strict means these are like two parts is generally to attention to. Not strict means that the memory symbols and the function names they are not like if you strip it, they'll be and the function names will be generally stated to be some and some random number that will be there. Now I'll execute the challenge and it's asking for the password. I'll enter something and then it gives a new try again. As you saw here, uh, if you get the flag, you get this string that comes with the output, and if it doesn't, yeah. So I'll now set IDA. Uh, I have IDA Pro right now, but I have set up a shortcut, so I can open it this way. Like if you don't have IDA Pro, it also works on like you can use IDA Pre on Vivo. Uh, you can analyze this statically, but like if you want to know how it behaves, I'll be removing it also. So if you want to know how it behaves, like during runtime, you can debug it. That's for IDA free. You can't do remote for IDA free, but like if you're on Linux and you have IDA free, you can do it on uh, local. So I'll start right now. So this is like every C uh, program has a main function. That's usually where the main part of the code is supposed to be. Here we can see like this part is basically what this means is uh, this means the command line arguments and this is the number of command line arguments and like this part of the code that is the command line argument. If I do something like this, the challenge requires like the flag instead of entering it over here. If it requires I enter it as an argument, that's where this comes in. Here it's not important. Like yeah, read this keyword is for Splunk smashing. Yeah, which will be running in pawn, which is tomorrow and day after. It is not really important over here. So yeah, as you can see, um, it's asking for a function, well, it's asking for the password, uh, printf, and then it's taking the, then it's putting that, uh, putting your input in S string like this variable, which has a size of 200. So previously already in C, it's the string data type is not defined. It's in that string is an array of characters, which ends in one. Here, it's putting that in this, and this function, like this, uh, string CSPM is registered to the new line character, and then replaces that with the main character. so that it becomes a proper string. Uh, and then Yeah, and then we continue ahead, and then you see there's like a shift, like a simple shift, as I said. You would see something like this over here. You can see some 1060, some 1080, things like that. It would swap like that. But here, since it is not strict, it is going up in its proper way, which I already defined in my challenge. Here, shift, fly shift, insert, and reverse shifts. All that is coming over here. Like now, if you when you do one, I showed you the strings in on Linux on MATLAB Linux. So the shortcut for idle is Shift F12 and Shift F12. It shows you all these strings that are available. Now, if you want to know where these strings are being called, like where they are being referenced, where they are being called from, uh, you can you can click on it. I'll go back to the You can double click on that string. It will show you that this thing. And then you can click this variable name as string call. And then you can hit X and then enter. This is assembly. This is the pseudocode. I don't see this is assembly. So this is like see like code. You can see assembly. So you can see like code pseudocode also. Depending on the challenge, usually pseudocode is much more helpful since you know if you know C, it makes it much easier for analysis. But sometimes ID, it's not properly able to display certain instructions, certain phrases if the assignment has been messed around with. So that's where assembly comes in. Yeah, like um, when you open item, it's not in pseudocode. Like if you have plan. Uh, if you have pictures one is great format. This is also like very helpful. Like it will show you the controls and stuff. And like here JNZ means it's not zero. If it's showing you can jump over here. Like, if we can like see there's one red line and there's a blue one. If it's one it will jump here, if it's two it will jump if it's one it will jump here, if it's two it will jump here. And then it will jump here and then it passes it. Yeah. So yeah. So if you want, you can look an assembly, but if it's not properly showing up in IDA, you can also make it pseudocode. You can look at an assembly. Uh, I'll be screening both during day parties. Mm. Yeah. So let's start with what the solutions are doing actually. Like if you look at this function again, the function is returning an int, which is this is basically it's a extract has happened. So yeah, which again you learn in tomorrow's session. Uh, so that this part is not usually important. Uh, now we'll go ahead. It's looking but we are messing around with our input. So like some will be returning an input. See, uh, if you pass a pointer to a function, even if you don't return it, it's still like if it's defined in the pointer function, it will store that value. Since you see, uh, everything is stored in a stack frame in stack frame. Uh, this means the stack frame for me is calling this stack frame for uh, shift list. This means it. So this thing, it's since it's available in way, even if you don't return, it, the value will be saved. Like you can see, destination, which is the final result of the operation, it's being returned to, it's being put, copied into string like this, and then it's not being written, but it's still being saved since it's pointer is being passed. So like if you look at the function, it's taking the string length of this thing, like it's not appearing here, but like depending on the comparison, it usually doesn't. So if you double click on it, this period, it's taking that string and then it is iterating uh, through the input, and then there are two loops, and it's outer loop and an inner loop. It's iterating through those two loops, and then if let's say before here, like if a certain index, like if the first if it starts at zero, it will iterate I zero and B double. Uh, since I'm on WSI, I have to note this about sure if Windows, Windows will make Windows affecting Windows, if Linux and Windows, but if Linux and Ubuntu, you can directly do it remote. And then if I make local, if I run, I will specifically continue. For debugging, you usually set a breakpoint. The shortcut for that is F2. So I'll set it over here. And if you want to remove it again, you put hit F2 again. So I'll put it over here. And I'll start debugging. And then it's asking for my input over here. So I'll hit a, okay. And then it's stopped over here. So there are two ways of stepping forward. It's F7, F8. F7 is step into F7, and if you press it, it will basically skip this function. It will go straight to the insert INS. Election section. Yeah. Uh, Second, it's basically like assign of GBB. So if I hit S9, it will go here. You usually want to skip the library contents since you already know what they'll be doing. So I'll be skipping them, and then now we come to the same part of this. Yeah, I is equal to 0. Uh, J variance equal to 0. Uh, we can select if you put it answer, it will show what value is stored over there. Here I see. Then if you look at this, yeah, 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 it's not. And then yeah, since it's if the index is 0, it will compare these two functions, like these two indexes of each string. So if they match, it will what is it? It's not again. It's not match. It will keep iterating till the till from till the input is zero. So till A is reached in this string, it will keep running through. I'll put a breakpoint over this. So we can skip that. Now, you see, for the breakpoint, you want to go to that breakpoint state, we can hit this now. Um, now, yeah, mm, here, you can't. Mm, mm. So what this is doing is it's basically it's basically taking that character, whatever I input is, each character it's taking, and it's comparing it to the string over to this custom list string, and it's increasing the it's taking the character which is 7 indexes ahead of it, uh, which is like if you put eight, it's 1, 2, 3, 5, 7, which is it's yeah, that's if I take X over here, so I hit with 7. Yeah, see, the first character transfer to X, like in destination. In the next all is it. You can keep doing that since I think all is, it will convert it to like all X. Everything will be X. This mode, this thing, it's right now it's not a it's a the length, like it's not it's even 20 minutes. Yeah, it's not the length of this thing. So I mean, see, uh, it's not like creative. Uh, Like even if you bounce, it will still index not a bounce. Even it will still gibberish noise, so you don't want them. You want to cycle through it. So if it reaches this closing curly brackets, you want to go back from zero and then you want to go through it again. Uh, so that's what that mod string is. Mod this thing is called. So again, I'll hit F9 and then 8 plus 7, and then you can see the second came as second is also H. It will continue doing that, and then put additional value. I'll remove this breakpoint and then hit of 9 others. Now you'll see that destination is 1H. So what this function is basically doing, it's increasing the index, like keeping characters, some characters ahead of our current character. So this thing, if you like, ask the haters, if after that it's some other like, it's the sure. It's not really useful. Um, yeah, so I think actually, but over here, yeah, maybe it's closing this. But I wanted my system like own custom last night this thing to me. So I put this like this is the ICS to this is what my like, this is all that forms this line. The and yeah. So it takes this function basically takes like the seven character line and then cycles through it. If it reaches time, it will cycle through to this one and then again it will do that again. Now let's see go to the next function. Insert so if you do inside uh like if you just look at it statically like without debugging, like just look at what the keyboard is doing. It's what it's basically doing is taking the rest again. Uh, it's it's taking our instrument and it's so we even uh, what do you know here? I see. Uh, hello? Is it clear now? Uh, we are just taking the net. Hello, like audio. Hello. Is it clear right now? Sure. Uh, uh, okay. Okay. Since the audio is not clear, I'll repeat myself again. Yeah, I'll go to the main. Yeah, so in IDE, uh, uh, there are you can view the code in three possible ways. One is this graph view, which shows you the assembly code along with like the control flow. Like yeah, you can see where it will go depending on this instruction. It's basically jump left equal to 0. That's what JNZ is. So if it's nice, it will jump here, and if it's not, it will jump here. And another is pseudocode, which is like C code. It's not C, it's C. So you can, this is the like, easier part. You can like understand. If you don't see, it's easier to look at this part and then look at what the program is actually doing. This is just pure assembly, pure assembly. You can look here. Mm, yeah. So like when you usually open IDE, you can open in pseudocode. Uh, and if you hit and if you hit tab, since if you hit like when you're opening, if you hit tab, it will show you this graph here, and if you hit space, then it will show you if you are assembly. Pseudocode is usually easier to work with. Uh, since like if you mostly it is easier to understand and stuff. But sometimes I don't. If the compilation has been mixed with, I don't can't run it. When it doesn't see the instructions properly, it will probably jump brackets zero at some random address will be there. So that's where this assembly view and this graph view comes into play. Graphy is also helpful when you are debugging it. So if you want to like patch your code, patching is you can look it up, but like you can where like if you go to edit and you can patch my password like over here. Let's see, over here. The it's provides like if you want to change it to like if you don't want if it's JZ of code is 75 if you want it to be JZ. JZ of code is 74. So I can change if you want to jump to this other part of the code, you can like change the another option is also just to change the instructions. Change um, um, assembly. Yeah, you can change straight from here, JNZ to JZ, straight from here. That is also an option. So before this, I was explaining what shift. There are three functions which are missing out with our input, and we're going to final check over here. This is our final string, this is our final string, which is it's being compared against. So these four functions, like function actually we mentioned the copy function is basically copying a string into like it's basically copying a string. So it doesn't really do anything. So actually these three functions, insert, shift, and reverse string. Reverse string, like I'll start from reverse string as since we are reverse engineering, since we need to get back this now, we start from the reverse. Uh, if you want to, like, that's usually how you do it. Like, you start, it's copy over here. So since it's not doing anything, we don't really care about it that much. Reverse string is when you go about reverse and when you rank the code, you first reverse the string. When you go inside the function is pretty like it's doing what it's doing because you can save the function. If it's stripped, the challenge is when the stripped with sometimes blank. So if you look inside the function, what it's basically doing is it's iterating through again. It's iterating through a string, and it's only going for half of a string. V4 is a string. It's only going for half, and then if you see, like there's no breaking condition is not over here. The only place it is breaking is over here. When I reaches half of the string. Uh, It's like if you look over here, V2 is like the first index is being selected V2, and then the last index V4 minus I uh, minus 1 minus I. Uh, it's being like this is not the time to do it. This short and I guess. Where is it? Uh, if you don't have also, I think three. um, If you don't have it, usually. Yeah. So it's like A is equals to ABC. Yeah. And then M output equals to CD and MT. And like if you go through for I am arrange len len a with temp is temp I is equals to uh, a and oh I will forward to put and temp and then a and over here it's in Python it will be minus one event virtual C. It's sort of having index in C. So here is the like reason is the string, so it starts with the last one. The string length like so string with length like like there are four characters in the string. So string length will be four. But since the indexing is starts from zero, when you want to go minus one. And then minus eight to decrease the index each string for each iteration. So it's like over here you can put I have a oh here I and then I is equals to uh, minus one. None is yes. Okay, minus one. Yes. And is like this is part equals to and a sorry. Oh, oh, shit. My bad. Oh, yeah. Audio is again not noticed. Is it moving right now? The error here came is because see, this is an empty string. That's why. Uh, if I do, oh, and there's another mistake over here. I have to put temp product. Yeah. And, uh, that is good. I think I'm sure. Okay. Is my bad. Mm, yeah, okay, this is all. So let's do it. Mhm. Mhm. This should work. Mm, mhm. Okay. Okay. So, alright. Full lag. Yeah. Uh, yes. Uh, I tried using my audio input to Max, I guess. Mhm. Okay. I'm doing something stupid with it. I'll increase it. So that's okay. We'll go with it. This- Yes. Yeah. I'm sorry. I'll switch back this video. Uh, yeah, mm, yeah, there was a, this part is like, there was interesting. Let's go back and then, this, uh, hmm. So this part, it again iterates through, all the, it again iterates through our input. I transform the input, and then if the index itself depends on input, to the source, and then if our index is like divisible by three, like zero, if like, like if if our index is not three zero, it will, depend, like, depending on like, yeah, depending on the index, it will one of these characters, into our class, to mess around with it. So like for this, uh, like if I can like a anything, like the first character it will put A in Sassy, and then it will, put A in Sassy, and then since, 0.3 is divisible by, like since it comes zero, and then if you do not zero, so if like, and since zero is false and every non-zero, this thing is, and every non-zero, integer, every non-zero integer is, uh, true. So if you do minus zero, it can, be true. So if it's like if the modulus by three comes zero, then it can be. So if A is anything, it can be. Then, since it's zero, then it can be zero of index. Like explanation will be appended. And then again it will go to like index three of our input. And then, we can integrate three of, after appending like, after putting three of those into Sashi, again it will be divisible by three, and then, and then it will be, again, concatenated at the end of the Sashi. And then again it will keep transforming, our input values. And in the end, you'll see it. You can see it over here. In the end, you can see like at the rate, like at the rate exclamation mark hashtag dollar. You can see like, stuff like that in our input. Like it's not already in this function. If you hit the escape, you can go back to the like previous function that it was being called from. Because as you can see, like at the rate, hashtag dollar stuff like that is already it's like it's there. So that's it. That's how that's happening. Shift characters. This is basically, like my own custom asking. As I would, yeah, as I would call it, I want like a slide. It will be only like made up of these, like this is an entire character of a flag. It can only be from this much. So, what this is doing is basically it's taking our input and it's, cycling, through, like, it's going to that like it's going through a list and it's going to that particular index where our input, like this our input character matches like the character list, and then it's, replacing that character, with like, this is like with some characters and then that is coming over here. Like this part, like if I put this, I it will like actually come over here. Uh, like if I put the, I will come over here. But if it reaches, like closing curly braces, then, like again cycle through. That's why the small, this is not really, which is like stringing. Again, I remember like, since I was new to the I really just to it's basically like it's for fractions. It's like a fact family. It's based on it. If you learn about like, the modern small fission. Uh, Yeah, so that's and then again, it's being the destination the final result of our uh, operating on a spring, and then it's again being routed to which is our input. Like it's like if you see here, like the return type usually tells the long here it's integer 64, like it's returning the 8-byte integer, uh, but uh, but that is just but that like over here it's not important. The important part is over here, string like as since in C, like even if you don't return like a pointer, if the pointer is like if you're passing a pointer to a function, even if it's like void and it doesn't return anything, like it's being saved since it's already like done in the quality function. Uh, so now I start and then STR is it's this is the input, this is the input part of the function, this is taking the input, and then STR scan is basically like replacing the new line of null. So it's basically forms a string in the end. Uh, yeah, that's a no one like since this is the behind is like all these three functions in order. So if you want to demonstrate, you start from the bottom. And the copy is basically like it's basically like copying into like this thing into another way that's only. So that doesn't really matter. String this thing reverse, it's still reverse. Well, yeah. So it might be this thing. This is this is the final result of the reverse. So if I take this thing, like SPR is equals to yeah. And then for and I'll make another uh, this thing. Uh, yeah, and STR. This is me reversing the reversing that string. Mm. So yeah, this is the reverse string. So we reversed one function. Now insert is since it's basically like since it's basically like adding all this like Japanese character we didn't want it. So like how is we can isolate the function and since it's like every like for every index which is using not tree. So it's these modular three is it's added not so for every element. Then for that index we know it. So I will copy that string again. Yeah. I will copy that string and yeah. Mm, array and index is all set to 0. And since you want to iterate for each of these, we have yeah, let's do it. So I go to it. I will str. Uh, I'll append first like since it's appending before adding that adding that this string, this particular or the any of these strings, I'll append that before and then this again I'll check for that particular index like this of um, since I've already tried this, it's appearing already. You don't really need this part much to know this part. It's not really necessary. Yeah, it's basically checking this thing. This. over here, let's say, the fitness checking is if the character over here exists in A, so that's not really necessary. Over here, like, yeah. And then it's ranking. It is like implementing more to, since you don't want that character to be offended, if you are increasing the PS sticking the character, uh, else we'll do uh, I plus one, I plus one. Uh, and then again, we are implementing like with, again, we are implementing, so that should, uh, like, give us, oh my bad. It was stored in a, oh, no, I messed up. Really down to the settings. Yeah, yeah, with this thing. Yeah, what it's I overlap like variable and overlap. So I have to go to the I think there was a problem before also. Like this thing and our loop again. Like how is I do things are it should come. I guess yeah. I got to change this SPR to a over here also SPR to a. Um, here it's B and then oh no, I'm not sure. I guess I'll just press it on that. Uh-huh. My bad. Since I already had that, so I can't like it will mess around. Like, it already had the previous before this one, this part, so I don't want to overlap. Uh, I is equals to zero. I put j is equals to like I start. Right. Yes, yes. Uh, yeah, I'll replace all CR with A since that's where our input is. Should be with no. Listen, yes, now it was. So it removed all those. Where was that? Where was that? Yeah, this thing. So this is like the previous. Uh, Before I removed that, and this is like after like removing all those special symbols like percentage and stuff. Like what this basically explain what this basically is doing. It first it defines that character, and then it checks for like as in the challenge. First it yeah. First it defines that character, and then it checks for whether it is divisibility, and then comes depending if it is like divisibility, it depends like this like the characters from among these to our source, uh, and then it goes to the next one, just like checks again and repeats that. So one we wanted to do all these was like functions like percentage, at the rate, hashtag, exclamation, like that's raised to dollars, stuff like that. So first, like I can get this, and then I check for it. If it was divisible by three, I skip the calculation, and then if it was not, I like again place one. Uh, so I ended up skipping all these special uh, like matches. Now they're renaming uh, this thing. This shift characters. Like this is the like this is one of the easier like uh, so this is since this is like adding like in shifting our character ahead by seven like shifting like moving up like taking the character seven characters ahead of our input. We want to like shift like from my transform also we want to be characters that are seven characters behind. So for that, again, I put like C equals to join R. Let's see if I do it. Now, Uh, I'll take this, like, since this is our first thing, not we like, if it was like Asper table, we wouldn't need this, but you could have just done -7 and cycle, and it would have worked. It would have worked out. But here, since it's not a first thing, Asper table, we have to remember this to be big. Oh, I already got this mix. Uh, mm, and then again R, and then for C. Oh, this Python are shared by memory, so it's showing up the code on Python. So if C in uh, LSP converts, I go in a moment. Did I define J? Oh, I don't remember this ends. Yeah, my bad. This is a primitive like, function like which gives you the index of that particular um, like, character or number in that particular array or string. So J will have now J has the like, index of C. Now we append we append with the character shifted back by 7. So C, oh, again this has this. If it was C, you would have to do like mod 10, sorry, mod 10 or something. Mod length is this thing, LST, but okay. Since -1 is like a valid index, it doesn't really matter over here. Uh, so like if you hit enter, uh, yeah, it's, uh, oh shit, I forgot. My bad. I forgot one thing. Um, else, if it is not in that, then I do R dot append. Uh, yeah, my bad. Yeah. It's- oh, I have to create R. Since R has all that already, I'll have to clear R again. Nice. I just copy paste from here. And then R dot append C. Oh, nice. Oh, I got again. I did. Yeah, I took STR again. Yeah, it's my bad. Oh, hmm where was the last this thing stored in? Mhm. Is it stored? Yeah, it was stored in C. Oh, shit. Uh, I'll take this since. Oh, that's. I'm forgetting. I've put these names already. C. D is equals to allow will have this thing, and then R again we initialize R, and then instead of strings we'll go through D. Hmm. Since this initialization. Yes. When was your plan for this challenge? Like, test it, I guess. Uh, like, if you don't know, like if you want to give where, like when you compile it, uh, it already gives like executable, but like if you want to do it in your own, yes, but you know, you can do child this is executable permission search can execute, and then if you run it, and you enter password, there you go, the file. So that's basically the routing challenge. And like, so I'll go through it again. Since the audio was not properly English, I was like, there was just of what uh, what the channel is actually doing. First, it basically took our input. It replaced the new line. So if there was a new line, it would replace it with like when you hit input, it replace that with uh, like when you like if you input over here and you hit enter, it gets that new line character. It gets plus that. And then if you like you need to like this much is replacing it with one line character. Shift character again, it's as I said, it's shifting our character ahead by 7. So to reverse it, we'll shift it back again. Insert string is inserting for every modulus by 3. It's inserting these uh, special like characters. We want to if you want to like remove it, again, we'll skip that character. I'll show you the code. Um, so this part of the code, we'll skip that part. Like this was its modulus by 3. Uh, then the last one, second last function, this is basically reversing. It only goes till, like reversing the string. It only goes for half the iteration. It's storing the first index to a temporary variable. It's like putting the last index. Like V4 is string length, so it's not like if you do one minus one, it will be the last index. So in C and most program languages, and like in this starts from 0. So we want if you like if you just take V4, it will be index out of bounds. And then you do -1 to decrease that index. It will means at the halfway point here, and then it is like interchanging from because it is 0 and this is of length like so it will like first like turn in 0. Then since 0 is already stored in the string variables 0 to 10, and then like yeah like 9 to 2, 2 to 9, 8 to 3, stuff like not 3, 10, yeah 10 to 0, yeah 9 to 1, 8 to 2, stuff like that. So this is basically reversing that string. Copy is basically just to copy that like string to another like to itself only. So it doesn't really matter. So to reverse it, you go like in the reverse like reverse the part is done. So this is the final input. So we want to like the last operation that was done on was copy. Doesn't matter. Reverse we reverse it. Insert like insert special characters. We remove those characters. Shift and then we like, shift is so out shifting. So we shift back. And then if you do well at the end of the class, reverse, yeah. That's how you usually go about reversing like reverse engineering challenge. Uh, yeah, you can if you have any doubts, you can ask them now. Like if you have any doubts. So since there are no doubts, if you can, we can end this session, I guess. Okay. So